So the second part of our lesson is word problems. And before you start groaning, think about the fact that you constantly wonder, when are we ever going to use this? Well, word problems is when we use math. Think about real life. Ever in real life will you encounter a situation where you're given a point and a slope and told to graph it or write an equation or put it in slope-intercept form? Probably not. But we have to look at that basic information before we can get to the when we could really apply the math. So a situation, Marty's spending money at a rate of $3 per day. He's spent $68, he has $68 after 14 days. How much money will he have after 20 days? So he may want to plan ahead. How long can he continue to spend this money before he needs to go find a job to support his spending habits? All right, so we're going to start by figuring out our rate of change. Now, when you're looking at a word problem, some keywords to look for, or at least one jumps out at me in this one, is per. Remember, rate of change is when you're looking at two different units in the same number. So this $3 per day is including the units of dollars and days. That's our rate of change. Now remember, rate of change is change in Y over change in X, and he's spending $3 per day. So our slope is -3, and it was dollars per day. So that gives us our Y value, or our Y unit, and our X unit. Our Y units will be dollars, and our X units will be days. So the next part that we want to look for is our point, our ordered pair. Now, looking at the slope, we know our ordered pair will be days and dollars, and I'm seeing days and dollars right here. So my point, and I'm going to label my units as well, knowing that my X coordinate is days, I'm going to put my 14 first, and then my $68 is my Y coordinate. So we're going to use point-slope form for our equation because we have a point and a slope. So we're going to substitute into our asylum equation. Our slope was -3. Now our 14 is positive. Once it goes in the asylum, it's no longer normal. It becomes negative. Our $68 is outside the asylum, so it stays normal. It stays positive. And what I'm going to do next to answer the question is rewrite this in slope-intercept form, because there will be a y-intercept that we can interpret that may help us answer this question. All right, so I'm going to start by distributing. -3 times 14 is 42. Combining my like terms, 40 plus 60 is 100. 2 plus 8 is 10, so I have 110, and that should be a plus sign, not an equals. So our slope-intercept form of the equation is y equals -3x plus 110. Now let's interpret our slope and y-intercept. The slope we already interpreted. It was he's spending $3 per day. Now the y-intercept, remember our y value was dollars, and the y-intercept occurs when x is 0. So after 0 days, he had $110. That's what our y-intercept means. So he started with $110 before he was spending $3 a day. Answering the question is, how much money did he have after 20 days? Well, remember, our x value was days. So we're going to substitute 20 for x and solve for y, the amount of money that he would have left. Multiplying -3 times 20, 110 minus 60 is $50. So after 20 days, he will have $50 left. One more example. This time, the math department sponsors a math family fun night each year. The first year, there were 35 families, and the third year, there were 57. Predict the number of families in the 5th year. All right, now I'm looking through this, and I'm not seeing the word per anywhere. So I don't know if I'm given a rate of change. And in fact, I'm not. I do see two ordered pairs. The first year, 35 families. Third year, 57 families. Now remember, when you're setting up an ordered pair, the x is the independent variable. And if there's ever time as one of your options, that's your independent variable. So I've ordered pairs 1 year, 35 families, and then 3rd year, 57 families. I'm going to calculate the slope, change in y over change in x. So looking at my y values, 35 plus what gives me 57. So my change in y is positive 22. And then looking at my change in x is 2. So I get a rate of change of 11, and let's label it. Y was families, x was year. So on average, we got an additional 11 families per year to come to our Math Family Fun Night. So now we're going to write the equation and then answer the question. So our asylum equation, substituting our slope and choosing either point. I'm going to choose my first point because the numbers are smaller. So my positive 1 goes into the asylum as a negative 1. My 35 goes outside the asylum as normal. Again, I'm going to go ahead and distribute my 11. Combining my like terms. And interpreting. We already interpreted our slope, 11 families per year came, an additional 11 families per year came to our Math Family Fun Night. And what the 24 means is that in year 0, 24 families came. So that was our initial value. Your y-intercept gives you an initial value. All right, now we need to answer the question. Let's scroll back up, and it said, predict the number of families in the 5th year. Well, remember our x-coordinate represented years, so we're going to substitute 5 for x and solve for y. And label your answer. Our y value represented how many families came to our Math Family Fun Night. So we got 79 families, or we expect 79 families to come in the 5th year. And your U-Try problem.